Só um momento, Matheus. Eu estou vendo aqui na programação era o trabalho do Meladete primeiro, do Meladê. Ele não está na sala. O Diniz, Meladê, ele não está na sala. Então, eu acho que eu também me confundi agora, porque o trabalho do Marcelo. Você estava previsto para agora ou para o segundo trabalho? O que você estava esperando? Está mudo. Marcelo, please. Your microphone.
O Marcelo é a segunda apresentação, tá?
Então.
Mas o meu...
O Diniz...
o Diniz não está aí ainda.
Vou chamá-lo, peraí.
Mas apresenta o Marcelo primeiro, depois inverte. Depois...
é que eu também de alguém
vai tentando achá-lo no WhatsApp, né?
Porque alguém pode estar esperando para assistir, né? Só um minuto. Mandei uma mensagem para ele. Mas acho melhor a gente começar mesmo, né? Até ele se preparar vai demorar. Bom, Marcelo, tudo bem para a gente começar, né? Bom, first of all, welcome to the second part of the STEP workshop related to the Latin American Dependable Computing Symposium. This second part have two presentations. First of all is a safety analysis of Brazilian suborbital launch operations based on system theoretic approach. This presentation is not ready to present now, and then we decided to move for second. And first, we present the second presentation related to cybersecurity and aviation, the STPA-SEC technique applied to the security of the TCAS. Welcome, Marcelo. Thank you for your work and enrich this workshop. And Matheus, please start the presentation.
My name is Marcelo. I talk about the application of the STPA-SEC method to analyze the TCAS security. The author of this work was the student Mayara Lapsalgado. She was the first author, and I am the second author. Okay. Cybersecurity aviation is STPA-SEC method applied to the TCAS security. I talk about the motivation, about the objectives of this work, I talk briefly about the TCAS, comment some TCAS vulnerabilities, and I'll present the application of this STPA-SEC to evaluate the TCAS vulnerability and we try to avoid that. Later on, I'll talk about the conclusions. Nowadays, there are increasing use of complex and highly integrated systems in the aeronautical industry. And there are new technologies like autonomous aircraft, machine learning, etc. The risk management in aviation and cyberspace has become each time more complex. In this context, this work presents the application of the STPA-SEC method to increase the TCAS security. The TCAS vulnerability to ghost plane attacks was analyzed. What's that? It's a type of attack in which imaginary aircraft, an aircraft that does not exist, is presented to the screen of the flight crew. They will have some responses that are not adequate. It's a dangerous attack, and it will be analyzed. It was analyzed in this work. Okay. Okay. What's TCAS? TCAS is the Traffic Collision Avoidance System. It's a family of aerial devices that work independently of the aircraft traffic control system, providing protection against aircraft collisions. Here we can see a physical architecture description of the TCAS. Right? I don't have too much time to explain each block presented here, okay? But later on you can see more information. The references presented in the work, okay? Here we can see an operational view. Okay, what do you have? We have a plane that I am showing here on the screen, okay? This is a plane that has their TCAS system, TCAS. This flying, then there are other airplanes close to nearby this aircraft. And this airplane is a threat. Why threat? Because there is a risk of collision with these two aircraft. That no one wants that. Okay, and the idea is to detect this airplane, airplane close to the first one, detect and try to avoid the collision. The idea is that. Okay. Here we have a functional architecture of the TCAS. Okay, each block represents a function. Like for example, threat detection, traffic advisory, then the different functions that the TCAS must have. Okay. Once we know what is TCAS, I will talk to you about some vulnerabilities. One of the vulnerabilities of this system of the TCAS is the spoofing. What is spoofing? It's modifying data that otherwise appears to be from a legitimate source, using protocol weaknesses, compromising security data, or compromising the terrestrial system. How would you, can I say you to your example? Yes, ghost aircraft, that does. In reality doesn't exist, but it's created false data, the data that is not real. And the pilot here, this airplane, believes that he starts to command maneuvers to escape for the collision with this imaginary aircraft. Okay, it's a dangerous situation, and it should be analyzed. It was in this work. Okay, we use the STPS-SEC method that it was developed by Professor Nancy Levison from the MIT. Okay, the STPS-SEC can be applied on different phases on the system development. It can be applied on the conceptual phase, on the architecture phase, on the design analysis phase. Okay. Here we have some steps for conceptual phase, for the architecture phase, for the design phases, then analysis phase. Then I show you briefly some steps performed by we. Okay. First, conceptual phase. What is the goals, the system objectives? First, a system, the TCAS is a system to monitor the airspace around the aircraft. They provide surveillance, traffic warning, resolution warning, right? And also it is a system that should detect threats in ghost aircraft scenarios. Okay, how it can be get this objective? TCAS detection mechanisms can make the system to function properly and to avoid the threats. Okay, the objective. What is the main objective? To avoid traffic air collisions and increase the flight safety. This is the main objective of this system. It's in the STPS-SEC method. It's important to define the losses, accidents that can happen. The losses, loss of life, critical data losses, loss of customer satisfaction, loss of airline reputation, all of that's presented on this on the screen on the presentation. Okay. Later on, we must define the hazard condition that is the cause to the losses. What is some hazards? I can say, for example, an hazard for unexpected crew responses to cyber attacks. Hazard 3, unauthorized message injection. Aircraft identity falsification, espionage, false trail appearance. And this is some of the hazards detected in the analysis performed. And each hazard is related to some losses, as is presented here on the screen. Once we have the hazards, we can identify security constraints to avoid that. I will say to you some constraints. For example, security constraint number 4. The TCAR system must be able to recognize the presence of a ghost aircraft that emits resolution advisories. Security constraint 20. The crew must be properly trained for scenarios of cyber attacks on the TCARs. Okay. And the other security constraint was written. Here we have more detailed security recommendations, constraints. Okay. Once the conceptual phase is finished, we can start the architecture phase. The phase in which there is the architectural description of the system. Here we have a picture of all the blocks, all the components that are part of the system. Beginning from this big picture representation, we can elaborate more detailed architectural description of the system. We use that architectural definition to find some unsafe control actions. For example, you say here, unsafe control action number 4. Aircraft considerably reduced the fuel level due to the change of the route. Causal scenario 1 for this unsafe control action. The aircraft has considerably reduced its fuel level due to the change of course after the attack. As a result, the aircraft is forced to make an emergency landing and is consequently unable to complete its mission. Once we have these unsafe control actions and these causal scenarios, we can define the security constraint to avoid that. For example, security constraint 2.2, when the fuel consumption, here in blue, when the fuel consumption is excessive due to a route deviation, the crew must estimate if the fuel volume will be sufficient to complete the mission. If not, the aircraft must perform an emergency landing or land at the nearest airport. This work presented the applications of the CTPS Act to increase the TCAR security. The work showed that it's feasible to use several references as a source of traffic to identify if the message is true. More detailed information can be seen on the report that is being published in this here in this conference. And there you can see more detailed data. Actions can take place in order to identify the mechanisms by which it's possible to create false trails and propose the protection against false alarms sent to the control tower and the defenses. The idea is that the TCARs does not avoid that TCARs follow false resolution advisories of ghost aircraft. This is the idea. The idea is that the TCARs function properly in real situations in which there are real aircraft nearby, and they avoid that the system responds to the incorrectly to the false to the ghost aircraft. This is the idea. To guarantee functionality and the security. With respect to the crew must receive appropriate training to ensure proficiency in the routine operation of critical systems. The final conclusion, the STPSF can be used to perform important security analysis. I hope that you have enjoyed the presentation, that you enjoyed the report, that you can read, okay? And I hope I and Nayara, that was the first out of the work, we expect that this work, this study can have contributed in some way to the flight safety and security as well. Thank you. I will respond to some answers now, and finish the presentation. Thank you.
Thank you, Marcelo. First of all, I'd like to please mute your microphone just in case to. Because I have a kind of echo in your microphone in the end of presentation. Okay. First, I like to ask for the audience if you have a question to Marcelo, please. Any have a question? I have a question, but
I have a question, Laura.
Please. Go ahead.
Marcelo, congratulations for the work. I would like to know in which project did you apply this technique? In a real system of TICAS.
What are your question?
If they applied this technique in a real project or just in a general system of traffic collision avoidance?
It was not a real plan. It was not a real TICAS. It was a model TICAS. It was a general case, not for any system in particular, not for any plane in particular. It was an initial study to applicate the STPA-SEC. We want also to study the application of the STPA-SEC on cybersecurity in one aircraft system. My student chose to analyze the TICAS, but only for a general TICAS, not any specific.
Oh, okay. I see.
I have a complementary question related to the Anna and another question. One is Anna, only for to say my opinion about TICAS and apply STPA. Have another studies using TICAS to exercise STPA, but the novelty of the Marcelo is used to security, I think. That is the real contribution of this approach. And my question is, Marcelo, the original study, application of STPA-SEC comes from Bill Young in the PAG study, the PAG proposal. And then my question is, when I try to apply STPA-SEC using the traditional, conventional approach proposed by Young is not so easy because we use more for war games and command and control systems. What are your impression? What are your opinion when you try to use STP-ASEC using the Bill Young approach? You think it needs more improvement in this approach, or is okay?
When I started to study STP-ASEC when I was guiding the work of the maturity. It was the first author, but we read that STP-ASEC has some advantages, but it has some limitations to apply to the cyber domain specifically. And this factor this factor was solved for some research that STP-ASEC has some limitations to apply that directly on the cyber domain. And because in security domain, there are some results which techniques were well developed. But we saw some publications of the new technique called as STPS Safe Sec. And this technique helps to use the STP-ASEC advantages, the techniques, and the cyber techniques of the cyber domain. I started to read about that. I would like to maybe someday to apply that technique, STPS Safe Sec, that integrates the cyber techniques on the cyber domain with the techniques of the STP-ASEC.
Well, what's the author you specifically mentioned about SafeSec? What the author?
I had some papers. I wrote 2 papers that applied that. Okay. One paper applied to the cybersecurity of the electrical energy plant to apply that. And if possible, there are some publications that this technique allows the integration of the STP-ASEC and the techniques on the cyber domain specifically. And there are some studies about that. But I try to answer your question. We did not try to use the technique detailed on the cyber domain. But I know, I believe that if you try to use it, we could see also some limitations on, specifically on the cyber domain. I suppose that the safe sec technique could be studied also as one more technique to evaluate the cyber security. But this is not my idea. This is some observations that I only saying again. But to me, it was novel, the STPS technique. It was a novelty to me, to my maturity. I don't know if I answer your question, Professor Carlos.
I agree with you. I think the STP-ASEC needed to more study case in the commercial domain also, not only in critical systems, but in all the kind of systems. They're very important to apply and improve the way to use the technique. That's the main goal. I think when more people exercise the application of STP-ASEC, naturally the techniques become more flexible and more capable to use in different kind of domains, I think. And then the second question is about I know you are long several years you start to use STPA and CAST in your studies, mainly university. And I like to know what today what's the level of technology and your experience with the students using STPA? What do you like to know about today? May I have more students applying STAMP?
I have used the stamp since 2014. The average one student for a year. Each year I have one student to analyze the stamp, but in most part of the time I and my students have used the CAST to evaluate the accidents that has passed. And the STPA exclusively, it was the first time that I used the technique, the technique STPA. And I would like to analyze more to STPA, to evaluate the safety and security of the aircraft systems, but only to the future. For a while, I only applied STPA once.
Okay, thank you. Any more questions?
I would like to thank Professor Carlos, Professor Hirata for the opportunity to participate on this conference, to publish these results. It was the first study of the SCPA to me, and I'd like to say that I can be more students to analyze this technique. I think it was elaborated technique that should be studied more. Once more, thank you.
We'd like to say thank you to Marcelo. You are part of the STAMP community in Brazil and also in Latin America. The idea, our idea is to, every year, since this year, to make a kind of a workshop to the people in Latin America to exchange experience and publish your papers and like it happened today in US, Japan, and Europe. Me and Hirata try to make a kind of a core STAMP group in Latin America also. Thank you very much. Okay.
Thank you.
Okay. Well, we will spend more time to the next presentation. Thank you, Marcelo. The speaker, I contact the speaker, the Diniz Melade, but unfortunately we try to enter in the system and have a problem. And we try now to try to enter, but I think it's better to play the presentation as me as author of this study. I open to answer the questions in the end of the presentation, and then for good conducting of this workshop, please, Mateus, play the last presentation. So
Hello, Carlos Gallas.
Oh, good.
Yes, I could enter here right now. Sorry for the wait. I was in a meeting with the Brazilian Air Force, and I'm sorry I could not enter before.
No problem. Open your camera to the people.
Unfortunately, I'm at work, and my computer here does not have a camera.
Okay.
I can try to enter in my cell phone, but I think it's not going to be a good signal of the microphone.
No problem.
So I think it's better to be here in the computer, but without a camera.
Okay, follow your video, and after that we are open to question and answers. Okay, thank you very much.
Sure, thank you.
To come with us. Please, Mateus.
Hello everyone, it's a pleasure to be here at the STAMP Latin American workshop. The theme of this presentation is Safety Analysis of Brazilian Suborbital Launch Operations based on System Theoretic Approach. This work counted with the support of the Brazilian Air Force, the Aeronautics Institute of Technology, and the Industrial Fostering and Coordination Institute.
I'm first lieutenant Diniz from the Brazilian Air Force and an aerospace engineer. The results presented here was obtained by the support of Dr. Engineer Carlos Gaos, Captain Silveira, and Engineer Sérgio Fujiwara. Nowadays I work for the Industrial Foster and Coordination Institute that, among other things, is responsible for the Launch Center Readiness Evaluation and Launch Vehicle Threat Approval. Of course, safety is important in launch vehicle operations. In 2003, a Brazilian launch vehicle had an accident that resulted in 23 fatalities. In 2015, a vehicle exploded in the launch trail, and in 2016 we lost a payload because of fin problem in the vehicle.
The objective of this work is identify hazards, unsafe control actions, and loss scenarios in Brazilian suborbital launch operations, aiming to detect means to minimize the effects of unsafe events or mitigate their consequences for future launch campaigns.
To achieve the objective, we are going to follow these topics. Brief introduction. This study is strategic because it deals with the preservation of human lives, properties, mission fulfillment, knowledge, and environment. The goal of this work is the analysis of systemic factors that influence safety, management, and mission fulfillment in launch vehicle operations. It was based on previous Brazilian launch campaigns from the Brazilian Air Force. This study used the System Theoretic Process Analysis, also known as STPA, that was developed by MIT. Talking about the systemic factors related to Brazilian suborbital launch operations, it comprehends any flight, pre-flight, and post-launch activities that involve hazards. We can highlight, for example, the system testing, the launch vehicle integration at the launch sites, the readiness review of the launch centers and remote stations for the operation, the acceptance review of the vehicle for launch. Regarding the selection of STPA as the hazard analysis methodology, it was considered published documents comparing the results of STPA application with the results obtained by other traditional techniques. It was also considered that the systemic approaches are most suitable for launch operations analysis that involves many stakeholders, systems, and processes, and also that STPA techniques are applicable for complex modern systems and operations. Regarding the STPA technique, for this study, it was performed the procedures described at the STPA handbook. First, define the purpose of the analysis, then create the hierarchical control structure, identify the unsafe control actions, and identify loss scenarios. To define the purpose of the analysis, it's necessary to identify losses, identify system-level hazards, and identify safety constraints. Now that we know the STPA technique, we're going to apply it for launch vehicle operations. To define the purpose of the analysis, it's necessary to identify the stakeholders in the system and their attributions. Included as stakeholders, we can highlight the users and customers, the supervisor and coordinator, the launch vehicle developers, the third-party analyzer, the payload developers, the launch centers, the remote stations, and the operators. Part of the attributions of the third-party analyzer, we can highlight the quality control, the launch center and remote station readiness review, the launch vehicle acceptance review. As part of the analysis, it was made a correlation with the stakeholders and the correspondent Brazil entities. For the third-party analyzer, for example, it was considered the IFI, the Industrial Fostering and Coordination Institute, and similar for all the other stakeholders. Then it's possible to identify losses for launch vehicle operations. First, loss of life or injury to persons. Second, environmental losses. Then, loss or disclosure of sensitive information. Loss or damage to public or private properties. loss or damage to the vehicle, loss of ground support operation, and mission loss. For the evaluation of system-level hazards for launch vehicle operations, it was possible to identify 10 hazards. For example, the damage of structural integrity of vehicle or the payload, and the premature ignition of vehicle stages at the launch rail. For each one of these hazards, it was associated the losses previously presented. Once detected the losses and the system-level hazards, we can proceed with the identification of safe constraints for launch vehicle operations. For each one of the hazards previously detected, it can be associated safety constraints aimed to avoid the occurrence of the hazard. For example, the safety constraint 1.1, the structural integrity of the vehicle and the payload shall be maintained in the worst case conditions. Related with the hazard 5, that is the ignition of the launch vehicle in the launch rail, we can see, for example, the safety constraint 5.2. In the event of unintended ignition, the vehicle must remain fixed to the launch rail, avoid unplanned roads. So each one of these safety constraints are like requirements to avoid the occurrence of the hazards previously detected. Proceeding with the STP application, we generate the hierarchical control structure. For that, we define the main controllers and their responsibility in the system. For each one of the main controllers previously defined, its associated responsibilities. These responsibilities defined here will support the generation of the hierarchical control structure. The third-part analyzer's responsibilities are related with tasks before the launch operation, during the launch campaign, and after launch. From the responsibilities before the launch operation, we can highlight the issue of technical reports regarding the acceptance review of the vehicle and payload for flights, and the issue of technical reports regarding the readiness review of the launch center and remote station for the operation. Proceeding with the analysis are proposed responsibilities for the other main controllers. As we can see here, the responsibilities are correlated between the main controllers. For example, in 5.3, carry out or monitor payload acceptance activities is correlated with the previous responsibility presented for the Space Safety Approval Evaluator. In the total, it was defined 69 responsibilities for the main controllers. Based on the controller's responsibilities and their relation with the Brazilian entities, it's defined the hierarchical control structure for the Brazilian suborbital launch operations. It's composed of loops of control actions and feedbacks that can be assigned here for each one of the stakeholders, and we can see, for example, in the third-part analyzer, that is IFI, they have relations with the producers and developers, with the supervisor, with the operators, and with the Brazilian launch centers. It can be generated this segmentation of the hierarchical control structure that presents the interactions with the producers and developers and with the facilities to track and launch the vehicles, highlighting some control actions and feedbacks that's going to be analyzed in this work. From the responsibilities of the Space Safety Approval Evaluator before the launch campaign, we can identify unsafe control actions for the analysis of the vehicle and payload for approval. In situations when the control actions are not providing and cause hazards, or they are provided and cause hazards, they are provided too early, too late, or out of order, or they stopped too soon or applied too long. Including unsafe control actions for conditions when FE inspect and audit the production and assembly of the vehicle and payload. Related with the control action when FE demands to the Brazilian launch centers the documentations applicable for the evaluations, we can highlight the UCA 17 related with the control actions that, when provided, cause hazards. The UCA is if it provides demands of the Brazilian launch center's documentation for the readiness review when the FE is not prepared to evaluate the documents and the launch center or the remote station are not ready for the launch operation. It is related with the hazards 2, 3, 5, 6, 7, 8, and 10 previously presented. It was also identified unsafe control actions for conditions when FE inspect and audit the launch center, the remote station, and ground support suppliers. For the UCA 17, the STPA was applied to identify the loss scenarios, being necessary to verify what are the causal factors that make the launch center readiness evaluation to be provided by the Space Safety Approval Evaluator when it's known that the launch center is not prepared for the launch operation. Related with this UCA occurrence, the identified loss scenarios are associated with causal factors, and it's provided a rationale. If the evaluation process to analyze the launch center readiness was updated and corrected, for example, it can be associated with throwing the modification of evaluation process, and to avoid it, the process needs to be updated properly for each system modification. Was identified for the occurrence of the UCA 17. This work proceeded identifying 8 loss scenarios. It's presented some further analysis for launch vehicle operations, finishing with a conclusion that summarizes the main topics of this study. In this work, it was defined that the STPA was the best hazard analysis technique to be adopted for launch vehicle operations. Applying at STPA, it was possible to identify 7 losses, 10 system-level hazards, 19 system-level safety constraints. It was generated a hierarchical control structure based on the 79 responsibilities defined for the controllers. It was possible to identify 28 unsafe control actions related with the responsibilities of the Space Safety Approval Evaluator. And from one of these UCA, it was detected 8 loss scenarios. Further analysis and application of this study can possibly to the improvement of the Brazilian space sector. This work used 28 references, many of them from the Brazilian Air Force and from version of MIT. We passed through all these topics, and I hope we achieved the objective, provide the means to minimize the effects of unsafe events or mitigate their consequences for future launch campaigns. Thank you all for your time. It was a pleasure to be in the STEMP Latin American workshop.
Diniz. Oh, sorry. Go ahead. Diniz?
Yes.
Okay.
Good afternoon.
Congratulations for your work.
Thank you.
I know it's a hard work. It's a part of your dissertation, master dissertation, and you work together. It's a very hard work, I know. First, I like to open for the audience. If you have a question, I have a question, but please first, any of the audience like to ask something to Lieutenant Diniz?
Oh, yes, Laos, I have
Please.
considered. Are you here?
Anna, some problem in your microphone, please.
It,
Repeat again, Anna, because it's have gaps in your talk. Anna? Anna, please. We didn't hear you. Anna? Well, before Anna start normally your microphone. Anna.
okay. Can you hear now?
Go ahead, please.
Okay. It seems a very complex and hard work. I have some considerations. The first one is, how do you have dealing with the growing of complexity? It seems that modeling the operation aspects of a complex system is so difficult and with many different aspects to consider, since it technical, human, communication. So how do you think in deal with this growing of complexity? Connected with this consideration is if you had difficult to maintain the traceability between among the control actions, hazards, loss scenarios. How do you have done it? Just using tables or a tool? How do you have been doing this kind of work?
Denise?
Hello, Anna. Thank you for your question. Hello?
Go ahead.
Hello?
It's okay.
Hello, Carlos Ross.
Okay.
Thank you for the question. Okay, perfect. So, first talking about the complexity, sure, launch vehicle operations and relating them with the Brazilian entities, it is complex because we deal with many systems, with human operations, with autonomous systems, with some stakeholders that are not, and we are aware about the complexity of the system and that we are not able to alone achieve or understand all of it. So to avoid some inconsistency or to do not declare something that is obviously wrong, we made like
Hello? Antonio? Denise?
interviews with the participants. It was conducted talks with the operators of the launch centers, with the developers of vehicle and payload in Brazil, and also with the supervisors, that is DCTA, in our operations. And from all of it, we started to create some considerations that could be achieved and to define responsibilities to create the hierarchical control structure, for example. And to start the unsafe control actions and develop the STPA considerations to obtain loss scenarios, it was focused on my work. So I work at one of the institutes that is involved in the Brazilian launch operations, that is IFI. And all the analysis that was after the modeling of the hierarchical control structure was analysis from this institute. So it was much easier to conduct the analysis and deal with this complexity because I could talk about and analyze something that we work with, and we have many people here. We work with this analysis, and it was easy to conduct the unsafe control actions and obtain the loss scenarios. Of course, the work, the further analysis are much extensive. We can apply this to all the other control actions. We was talking about just one of the control actions from one of the activities that the third party analyzer, that is the fee, does. We can do that for the launch centers, for the operators, for the developers, and they obtain much more safe control actions and much more loss scenarios. It's not a completed analysis, it's undergoing. And to complete this and deal with this complexity, it's necessary like organization, or not organization in the work, but organizational, that involves like the supervisor and all the other entities and stakeholders working together to obtain the unsafe control actions, the loss scenarios that are applicable. Okay, that was the first question from Ana Maria. The second one was about the traceability. In this work, we presented like 69 responsibilities that could create the hierarchical control structure, and from them we obtained just the unsafe control actions for the activities from the third-party analyzer. That's one of the entity from the stakeholders. And because of that, we obtained 28 unsafe control action. It was not a huge number. If we conducted the analysis for all the other stakeholders and with the activities not just before the launch campaign, but also during the launch campaign or post-launch activities, we could obtain much more unsafe control actions. And sure, it could be hard to make the traceability for all of that. How the work, because of the work was not so developed at this point, it was not hard for us to trace these 28 unsafe control actions with the hazards, with the losses, and with the loss scenarios. Okay?
Maybe I complement some?
Sure. You was part of the analysis and the work. Thank you.
Diniz, you used a tool to make the control structure, the diagram of control structure. Mm-hmm. But now it don't have in the market on the universities available of a tool to completely life cycle of a stamp. I think. Professor Hirata, we invest in this matter. I don't know if Hirata like to mention something about this kind of tools to use to stamp. Hirata, you heard us?
Yes.
You like to talk?
Yes, we developed one tool. Is just first was a prototype, and it's analyzing the safety aspect. Is a web tool. It doesn't require any specific installation. But the problem is that since it is web based, it depends on the performance of the server. So it might be a bit time. I would say a long period to get the response. We are now. We just finished another prototype. Is not that's the application. It's the software that you install in your computer. It's more elaborate because it can analyze safety and security, and it's more powerful because it uses the ontology to I would say to make the analysis easier and more consistent. So I think I hope in the next conference, STEM conference, I can present it to people. But it's open. If anybody wants to use it, we're going to use a project right now. and so it's open. It just talk to me, but you haven't disclosed the two because I also have some issues with the paper publication. Okay.
Good. Very good
Okay.
initiative. Denise, please put in the slide number 29, please, because I have a consideration, very interesting consideration about your work. And that's next, the 29.
Sorry, I have to find it. Which is the 29th?
Two more. More two. Here. It's very interesting to think about when you back.
Sorry.
Here. I think when you present some things about you, when you suggest some recommendations, safety constraints will become recommendations used, for example, when in unintended ignition, you keep the vehicle in the ground. I think a good suggestion is if you work your work for a next step, if he must to have another step, to review the new system in case you are implemented this recommendations. Because, for example, when you implement new safety recommendations, the system change. And the system change, you need to apply again the STPA, because keeping in the ground, keeping the ground the system, the vehicle, it must be implicating another hazards.
I agree, and for sure, for that, first we need to implement and verify how it was implemented, the recommendations, the safety constraints, and after that, we need to verify if these modifications, any modification, or like if it's a software or hardware modification, what was the effect, not just for this system, but in the systems related that could be affected. So for sure, after a new implementation after the implementation of the recommendation safety constraints, it is necessary to verify again, like how it's the system working, how is the launch operations dealing with the new complexity that was created by the implementation of the safety constraints and requirements.
Not introduce new risks. That's
yes.
New hazards. That's
sure.
It's a cycle work. You need to make new verifications, new validations after you suggest new constraints.
Yes, I don't know if Joe Castillo it's here in the conference, but he was making a work with Active XTPA that just do like that. Like after we have a plan of STPA and we start the application of this analysis, we can map how the recommendations, the safety constraints, and the requirements are dealing with, and what the effects of them to the system and to the stakeholders, to the other entities related.
Okay. Thank you, Denise. Have any more questions, or we could finish this presentation? Any questions? Well, thank you, Denise, again. Thank you all for the opportunity to share the experience. Professor Hirata, you have any comments for conclude this section?
Yes, just one remind that on Thursday you're gonna have you're invited to talk. Professor Levison from MIT. She's going to present the research challenges related to this stamp, I think it will be very, very interesting. I think is worth watching.
Yes.
Okay.
Don't forget that Thursday, in the 11 o'clock, 11 a.m., have a invited speaker. Okay, Dr. Nancy Levinson. Please, I invite you to take part of this good opportunity to share ideas with Dr. Levinson. Thursday, 11 a.m. Okay, thank you very much. And now we conclude the workshop. Thank you, Ana. Thank you, Nuno Laranjeira, for your amazing collaboration with us to make possible this work, this first workshop, this first. Next year, I have another one, okay? And
yes, and to finish here, I would like to thank you, Irata and Laos, for all the effort to make this workshop working. And I hope everybody has enjoyed and appreciate the information about this subject. It was very interesting. Thank you for the effort.
Thank you all. Thank you all the presenters also for making this possible. Because if you don't have your papers, don't have a workshop. Thank you for all the presenters, the morning and this afternoon. And we finish the workshop and see you Thursday to the Dr. Nancy Levinson invited speech. Okay? Thank you very much.
Ok.
Bye. Matheus, eu preciso falar com você um instante. Matheus? Você está aí, Matheus? Matheus? Matheus Martins?
Oi.
Matheus, pode parar de gravar?